Welcome to the project demonstration of wide input voltage application of DC to DC converter as LED driver project. So in this one we are mainly providing input of 230 volts AC inputs. The purpose of this project is by varying the input voltage within the ratio, then the output voltage has to be boosted up to double the input voltage, and when it crosses some threshold value, then the output has to be provide the same as input voltage. So in this project mainly it is as a boost converter along with maintaining the same output voltage. So the boost conversion operation range is 18 volts to 20 below 25 volts. 18 to 25 it will boost up the input voltage to output of double the voltage, and whenever it is above 25 volts, whatever the input is there, you'll get the output as it is. So that will be given as input to the LED driver circuit board we are using. So in that the stages are mainly 230 volts AC inputs, and the AC will be stepped down to the 24 volts of AC, and the 24 volts of AC is input to this RPS, that's the RPS board, which will take 24 volts AC input and provide us the along with the DC output voltage up to 48 or 50 volts, and that has to be the fixed voltage, and we need to do the regulation to that, means we need to vary the input voltage. So there we comes to the DC to DC converter along with LM2596 voltage regulator. So by varying the potentiometer, we are going to increase and decreasing the voltage within the region of 0 to 48 volts, the input voltage from this SMPS. So the output voltage of this LM256 voltage is given as input to the microcontroller, that is we are using ESP32 board. So that is input through this voltage sensor. So we are using the voltage sensor of 10:1 voltage ratio, that is a potential divider. So whenever the input voltage of 48 volts to this voltage sensor, the output of this voltage sensor is 4.5 volts, as we are using the 10:1 potential divider resistors, that is 10K is 1K ohms of resistance on these two boards, two voltage sensors, as we are using the closed loop DC to DC boost converter. So the input voltage measured by this voltage sensor and the output voltage across this load is input to the ESP32 with help of this voltage sensor, so that it will keep on setting the output voltage based on the input trigger voltage. That is, if it is below 25 volts, above 18 volts, it will make it as a double the voltage, and till that it keep on increasing the pulse signals to these stages. H bridge 1 we are using, and there is a resonance bridge we are using here, along with the inductive circuits, and the output stages directly given as input to this load, that is input to output of maximum of 48 whenever the input voltage is 24, and when it is above 25, then what is the input is there, directly we are getting the outputs. So here the components, this one is the breadboard to distribute the 5 volts power supply which is getting from this adapter, so which will take 230 volts AC inputs and provide us a 5 volts DC output. The output voltage of this adapter is input to this breadboard, and from there we are distributing that throughout the relay and this ESP32 module and LCD display, which was interfaced to this ESP32 by using the I2C protocol. So here let us see demonstration. The first step is we need to on the power supply to the transformer, that is the AC inputs, and next on the power supply to this ESP32. So now welcome to the project, message displayed on the LCD screen, and as of now we have set for 21 is a V in. So from this we are setting that 21, so that's why the V out is 42. So if we decrease that below 18 also we can get, but the output is constantly set for 36 is the minimum boost up voltage. So if it is less than that, automatically the load will be off, as there is no sufficient voltage for the boost up. So minimum of 9 volts should be required. When it is near to 18 volts, 19 for example, so when it is reaches 19 volts, then the voltage of 38, as we decided, the output should be double the input voltage. And when we set for 22, so 44, right, when it is 24, the output should be 48. When it crosses the 25 volts, then from 25 onwards directly it is going to be the input to output ratio directly. So we can see the output like intensity is increasing, right. Whatever the input is there, directly we are getting the output voltage. again when it is come down to right. Now the voltage has to be stepped down from 48 volts to 36 volts slowly, as the system keep on decreasing the duty cycle along with frequency to the MOSFETs on the H bridge. Then we are going to get the less voltage, right, and again increasing that. Right.